Hi guys, this is Miss Igo. Welcome to my classroom. In today's lesson, we're going to be talking about annuities, future values, present values, and amortization. Many financial institutions involve a sequence of payments at regular intervals, such as weekly deposits into a savings account or monthly payments to loans. A sequence of equal payments made at equal periods of time is called an annuity. The time between payments is called the payment period. The time from the beginning of the first payment period to the end of the last period is called the term of the annuity. The future value of an ordinary annuity refers to the total amount of money accumulated into the fund after a set period of time, and that can be calculated by using this formula. So these two formulas are the same formula. The variables are just a little different. In the first formula, the I represents the interest rate per period, and you'll notice it's in two places. In the second formula, this is the rate divided by the number of pay periods per year, which would be the interest rate per period. So dividing the rate by the number of pay periods per year is how you would get I in the first formula. Again, in the first formula, the N represents the total number of payments. In the second formula, N stands for the total number or the number of payments per year times the total number of years, which would be the total number of payments. So these two formulas are the same thing. For the rest of the variables, the FV stands for the future value. The PMT is the payment at the end of each period. And we've already talked about the I, the R, the N, and the T. So let's apply that formula to a real-world example. A college professor contributes $1,200 at the end of each year to their IRA. For the past 10 years, this fund has returned 4.25% compounded annually. How much did the professor earn over the course of the last 10 years? So this is talking as if it's the present time, but we're going to use the future value formula because all of this information that's given to us is the information at the beginning of the term. So here is the formula again, and we're going to use that to find how much the professor earned over the last 10 years. Okay, so we're looking for the future value, and the payment is $1,200 because he contributes $1,200 at the end of each year to his IRA. So we're going to put $1,200 as the payment. All right, and then in here we have 1 plus the rate, which is 4.25%. Now, in all of these formulas that we are going to be working with, we always, when we put the rate into the formula, we want to change it from a percent to a decimal. And just remember, always when we're changing from a percent to a decimal, we move the decimal point 2 places to the left. So that would give us 0.0425. That's over the number of pay periods per year. So since he's doing this annually, that just means once a year. And then we're going to raise it to the N times T power. So again, in this formula, the N just represents the number of pay periods per year. So this is going to be raised to the 1 times the number of years. So we're doing this for the last 10 years. So it's 1 times 10 power minus 1. And all of this is over that rate divided by the number of times per year again. So we have the 0.0425 divided by 1. And all of this can be put directly into your calculator. And once we do that, we get that the future value, or the amount that he earned over the last 10 years, was $14,575.47 if we round to the nearest cent. Let's look at one more example for finding the future value. A typical pack-a-day smoker spends about $170 a month on cigarettes. Suppose the smoker invests that amount at the end of each month in an investment fund that pays a return of 5.3% compounded monthly. What would the account be worth after 40 years? So once again, we're going to use that same formula, and we're looking for the future value. So the payment amount, they're going to make a payment of $170. And that's times 1 plus this rate is 5.3%. Again, we're going to change it to a decimal by moving 2 places to the left. So that would give us 0.053 divided by the number of times per year. This is compounded monthly, so that means it would be 12 times a year. And then we're going to raise it to a power, and the power is n times t, so the number of times per year times the number of years, so this is 40 times 40 years. And again, minus 1, and all of that is over the rate divided by the number of compoundings per year. And that would give a future value of $280,686.25. The present value of an ordinary annuity refers to the total amount of money that must be deposited today to provide all the payments for the term of the annuity, which is calculated using this formula. So again, these two formulas are the same, except for this first formula is using I instead of R over N. Another different, and then of course, we're looking for present value instead of FV, future value. And if you'll notice, these exponents in both are negative. So make sure that when you enter this into your calculator, when you negate the exponent, you're pressing the negative sign and not the subtraction sign. Here, of course, after the 1, you'll be pressing the minus sign. But when you try to negate that exponent, make sure you're pressing the negative sign button. So these payments, again, are the payment at the end of each period, and we're going to use these formulas to find the present value of an ordinary annuity. You're finally graduating from college and you decide to contribute to an endowment fund at your alma mater. You decide to give $500 at the end of each year for 10 years. The endowment fund earns 7.5% interest compounded annually. Your friend wants to make the same contribution, but instead wants to make a single donation today. How much money should your friend contribute to equal the amount of your donation? So let's use the present value formula. So we're looking for the present value, how much your friend needs to contribute today to equal the same amount of your donation. So your payment was going to be $500 a year, and that's times 1 minus 1 plus the rate. Once again, the rate, we need to change it to a decimal, so we're going to move the decimal 2 places to the left, which would give us 0.075. And you are making this contribution at the end of each year. So that would be once a year, and, well, the interest is compounded annually. So that would be once a year. And we're raising that to the negative number of times per year. So that's annually for 10 years. So 1 times 10. And we have the same rate, 0.075 over 1. And if we enter that into our calculator, we should get a present value of $3,432.04, rounded to the nearest cent. You unfortunately were in an auto accident. You sued the person at fault and were awarded a structured settlement in which the insurance company will pay you $600 at the end of each month for the next 7 years. How much money should the insurance company invest now at 4.7% compounded monthly to guarantee that all the payments can be made? So again, we're looking for present value, and we're going to use that same formula that we just used in the last problem. Okay, so we're trying to find the present value, and it says that their payments are going to be $600 times 1 minus 1 plus our rate changed to a decimal would be 0.047. Okay, and they're paying you at the end of each month, so that's 12 times a year. That's raised to the negative 12 times a year for 7 years. And again, we're going to divide that by the rate times the number of compoundings per year. So 0.047 over 12. And put all of that directly into the calculator. And so we're going to get a present value of $42,877.44, which is the amount that the insurance company needs to invest now to make sure that they can pay you $600 a month for the next 7 years. When you take out a car loan or a home mortgage, you repay it by making regular payments of equal amounts. This loan is said to be amortized. Both the principal and the interest are paid by a sequence of equal periodic payments. The formula for amortization payments is these two formulas. Again, these formulas are the same. We've used all of these variables in the previous formulas. And again, the I represents R over N. This N represents the number of pay periods times the time. In April 2013, the average rate for a 30-year fixed mortgage was 3.43%. A down payment of 20% must be made on a home that costs $272,900. In the first part of this example, we want to find the monthly mortgage payment. So let's look at the information that they've given us. And if you'll notice, it says a down payment of 20% must be made on the home. So we aren't going to use this whole amount to figure the amount of money that, or the payments that we're going to have to make, because we're going to take 20% off the top of this. So first of all, we need to figure out what 20% of this total cost of the home is. And anytime we're trying to find the percent of an amount, all we have to do is multiply it times that percent. Again, we're going to change it to a decimal. So this 20%, if I change it to a decimal, it's going to be 0.02. So if I just multiply this 272,900 times 0.02, that's going to give me 20% of that amount. 20% of $272,900 is $54,580. So, of course, to get the amount that we need to be figuring the mortgage on, we need to subtract $54,580 from the beginning amount, or the cost of the home. So if I do that, that gives me $218,320. Okay, so this is the amount that we're going to be working with. This is the amount that we need to find the payments for. So to find the payment, we're going to use this formula that we just talked about. Okay, so we're looking for the payment, the monthly mortgage payment, and that's going to equal the present value, which is the $218,320, times the rate divided by the number of payments per year. So the rate is 3.43%. Change that to a decimal, we get 0.0343. This is monthly payments, so we're going to be dividing that by 12. And that's over 1 minus 1 plus our rate of 0.0343 over 12. So I put this fraction into a parentheses. That's not necessary if you're using the TI-36X Pro. If you do, though, put that in parentheses, make sure that this whole 1 plus the rate divided by the number of payments is in a set of parentheses, because all of that needs to be raised to this power. So it's raised to the negative 12, because that's the number of payments per year, times the number of years. It's a 30-year mortgage, so times 30. Okay, so all of that needs to be put in your calculator, and that would give us a payment of a monthly payment of $917.84. After 10 years, approximately how much is owed on the mortgage? So to find how much is owed on the mortgage, to find the balance on the mortgage, we are going to use this formula. So again, these two formulas are the same. The B stands for balance. This is the payment amount that we just figured. Again, we have I here and R over in here. The only variable that we have not had so far is the X, and that's just the number of years that the payments have been made. So let's determine how much is owed on the mortgage after 10 years, and we're going to use the formula that we just looked at. So to find the balance, we put in the payment amount of $917.84, and that's going to be multiplied times 1 minus 1 plus our rate changed to a decimal, which would be 0.0343, divided by the number of times per year. So this is a monthly mortgage payment, so that'd be 12 times a year. And that's raised to the negative, okay, the number of times per year, 12 times per year times the 30-year mortgage. But we're going to subtract the payments that have been made. So it's monthly payments, and we've been paying it for 10 years. So we're going to subtract the 12 times 10. And again, all of that is a negative exponent. And all of this is divided by the 0.0343 divided by 12 fraction. And we would just put that in our calculator, and we get that the amount that is still owed after 10 years is $156,462.23. Now the next question asks how much interest will be paid on the total amount of the loan over the course of 30 years. So all we have to do to determine that is we take the cost of the payments, $917.84, and we're going to multiply that times the number of payments. So we know that we're paying 12 times a year for 30 years. So 12 times 30 is 360. Okay, so that's how many payments we're going to make. $917.84, 360 times. And that gives us a total of $330,422.40. Now, that's how much you paid total over the course of 30 years. To find out how much interest was paid, this is how much we paid total. So we want to subtract the amount that we took the loan out for, which was the $218,320, not the original cost of the home, because remember we paid 20% up front. So we're going to subtract the amount that we took the loan out for, which was $218,320. And that tells us that we paid $112,102.40 in interest alone. I hope you enjoyed this video, and I hope that it really helped you out. If it did, make sure that you share it with your classmates and be sure to subscribe to my channel. Thanks for watching.